So we're going to talk about different things called theorems, which we've introduced one of them already. Okay, but a lot of these theorems I've actually already talked about in class. I just didn't tell you that it was a theorem because I didn't want you to like freak out because that sounds way scarier than it actually is. Okay, so first one, we've already talked about this. So we started talking about the remainder theorem, which states that the remainder I get after completing either synthetic or long division, that value is the evaluation of the function. Okay, so this was actually the last thing we did on 3.6. And we used synthetic division just because that's the one that is probably going to be the easiest for us. Okay, so we're going to repeat that. We're going to do a couple more examples. Okay, so what this is telling me is, given the following example, evaluate using synthetic division. Okay, so if you remember, when we evaluated in Unit 1, so if I had something that looked like this, f of 2, and I was plugging it into this big polynomial, I would just go to every single x and plug in that 2 in parentheses, and then type that in my calculator. I'd get an answer, and that would be the answer. Okay? What this theorem is telling me is that I can do synthetic division and get the exact same answer. Okay? They're going to end up being the same thing. Why is that important? It's just a theorem. Okay? State of Missouri wants you to know that, so that's why we're teaching it. Okay? So what this is telling me, f of 2, so 2 is going to be my ledge guy. It's telling me to use 2. And then I need to put my numbers of my polynomial going across. What are they? 3, 1, 1, negative 5. I didn't have to do any placeholders there? Nope, because we went from x cubed to x squared to x to the first to nothing. Okay, we didn't skip anything. And now we just do synthetic division. So go ahead and try that. We just did one in our warm-up. All right, who's got the easy job? 3, it just drops down. And now we multiply that 3 by our ledge. What's 3 times 2? 6, add them up. 7, multiply. 7 times 2. 14, add them up. 15, multiply. 30, add them up. 25, awesome. So my remainder is 25. That's it. That's my answer here. F of 2 equals 25. And if I went and I checked it, if I double checked it and I plugged this in, I should also get 25. So if anybody did that, hopefully you what? You got 30? Okay, try it again. Okay, it is 25. All right, I want you to do the next one. Same thing. Okay, f of negative 3. Use synthetic division to find that for me. Okay, I like what I'm seeing. So my ledge term was negative 3. Good. And my numbers going across are going to be the same as what they just were. We're using the same polynomial. So 3, 1, 1, and negative 5. Leave a space. Help me. Help me, help me. Drop down the 3. Times them. Negative 9. Yep, add them up to get negative 8. Times them again. 24. Add them up. And then negative 75. And then negative 80. Good. So negative 80 is my answer. F of negative 3 equals negative 80. And if I plugged in negative 3, I would still get negative 80 if I wanted to double check. Did anybody double check it? Yeah, did it work? Sure? Okay, I believe you. All right, next thing. Again, this is something that we've already talked about. We're just putting a title to it, okay? It's called the factor theorem. This means that if I'm dividing and my remainder is what, then the value is a factor. 0. Yeah, if I get a 0 remainder, yes, that's a factor, okay? We've actually already done a question just like this one, okay? So I would like for you to go ahead and set this up. Set up synthetic division on this one. Just like the warm-up, it's just a little bit longer. So try it. I like what I'm seeing here. Okay. Ledge term. How do we find it? Set our factor. Guys, the side chatter's got to stop. Come on. Help me out. My ledge term's going to be what? -4. Good. The numbers going across are going to be what?
5, 16, -15, 8, 16.
Good. Good. Okay. Now what?
Now
Drop down the 5. Okay. Add them up. -4. Good. Yep, our remainder is 0. Good. So, is x plus 4 a factor? Yes, x plus 4 is a factor. Okay, so x equals -4. Guys, please stop talking over me. X equals -4 is our first answer, our first solution to this. Okay, how many more solutions will there be? A total of 4, because the biggest exponent is 4, but that would mean 3 more. Okay, so we would have to keep going to find the rest. Okay, and that's going to be a big part of what we do today. Okay, so on this next one, it says, first of all, find out, is x plus 2 a factor of that polynomial? You're perfectly capable of doing that, so go ahead and do that. Okay, and then pause, and we'll do part 2 together. There is a typo on this one. This should say -6x to the second. Sorry about that. I forgot. Okay, my ledge term is -2. Good. Perfect. Drop the 1 down. Yep, 1 times -2 is -2. Add those up. Gives me -8. Multiply again. Add them up. Multiply. And my remainder is perfect. Okay? My remainder is 0, which means I can go ahead and box in my first solution. And I recommend always doing that. Once you've found the first solution, box it in so you don't forget about it. Okay? How many more solutions do we have to find? 2, because there's a total of 3. Okay, so we've talked about this already. What we have here now is a polynomial, but it is in disguise. Okay, I need you to write down what that polynomial is. Okay, write down what that polynomial is. We see a 1, a -8, and then a 15. What polynomial is that going to be? Write it down. Okay, if we were to work to the left, okay, remainder is 0. That's not something I need. Okay, I'm done with that. Now I've got a 15. What does that have to be? Think about the order of this polynomial going to the left. So the 15 just has to be the regular constant, okay, the number by itself. Moving to the left, what would come after the constant? Yeah, -8x. Good. And then what comes after x? X squared. So 1x squared, or just x squared. That's it. Okay? Questions there on how we got that? A little bit? What's your question? Do you have a question, or are you just confused?
No, I said no.
Oh, well,
I didn't even say it.
sound like you said a little bit. Whatever, dude. Okay, now we set this equal to 0. Have we solved an equation that looks like this? Absolutely. This is what we did during Unit 3A. Okay, so we've got 0 on a side by itself. We're good to go there. We've got 3 terms. What should we try? X method. What do I put on top of the x? 15, and on the bottom? 2 things that will multiply to give me 15, add to give me -8. Are they both going to be negative?
Yes.
Okay, does it matter what order? No, so it doesn't matter what order you put. Okay, now what are we doing with those? Yeah, we're plugging them in. Those are the two new middle terms. So we got x squared minus 5x minus 3x plus 15 equals 0. What would I do from there? Yeah, group them. Finish this. So go ahead and do it. Figure out what your next two factors are going to be. Okay, when you group these up, x squared minus 5x goes in parentheses, plus sign, negative 3x plus 15 equals 0. The first two, what do they both have? X, and what's left? Good, the next two, what do they both have? Yep, negative 3, because that leading term is negative, and what's left? X minus 5, do they match? Yes, so my two factors are going to be x minus 3, x minus 5, and what was the first one? That was a root, that was a solution. X plus 2 was the actual factor. Good, okay. Good. So if then I had to write what the solution or the root was for the other two, I already solved x plus 2 equals 0. Let's do the other two now. X minus 3 is 0, x minus 5 is 0. What would those be? Just 3 and 5. Okay. And then if I actually wanted to write these as zeros, all a 0 is just an x-intercept. So if I had to write negative 2 as an x-intercept, it'd just be negative 2, 0, 3, 0, and 5, 0. Okay? Do you have to write all three of these for the test? Absolutely not. Okay? You do not. Okay? The main one we really want to look at is the roots, the solutions here. Okay? I'm just showing you what those different, these are pretty much synonyms, but they just look a little bit different. They're all the same answer though. Okay? When we get into our graphing next semester, we're going to do a lot of Desmos stuff, and that's when we're going to be looking for these points when we graph. Okay? Any questions? No? How we feel about this? Not too bad? Okay, so for this question, guys, I told you pretty much, okay, well, I've asked you to find it first, and we did prove it. But I told you what the first factor was going to be. It was going to be x plus 2, okay? Or x equals negative 2 as a solution. What happens, though, when I don't give you the first one, okay? When I give you just a big old polynomial, and let's say it has 3, maybe 4 answers, and I say you got to find them, okay? That is where this theorem comes in, and we've not talked about this one yet. It's called the rational root theorem. The rational root theorem. Anybody heard of this? No? Okay. If you go on to take college algebra, this will come back to you.
Do you have to take another math class?
After this?
Yeah.
Are you going to college?
No.
Then you probably want to take college algebra. It's required by most majors. Okay. So, if I give you a polynomial such as this one, okay, and I ask you to solve that, tell me what the answers are going to be. How many answers are there going to be for this? 3, because the biggest exponent is 3. Okay, but I'm not giving you any of the answers. I'm telling you to find all 3. Okay, so in your mind, you're going to think, okay, is this set equal to 0? Because that's the first thing we do when solving equations. So I would just want to change this f of x to a 0 on that side, which is fine. That's easy to do. Okay. Then I would see, can I factor that? Okay, and in some cases you're going to be able to, just like we did in Unit 3A. Okay, if it was a trinomial and the x method worked, great. If it was a trinomial and the x method didn't work, we could use quadratic formula. There were easy ways to find both answers. Okay, but sometimes, here I didn't write that in there, quadratic formula. But sometimes we're not going to be able to factor it. Sometimes they're going to get so big that we only know what to do with 4 terms as grouping. We don't know what to do with 5 or 6 terms. We've not learned anything about that, okay? Of course, we could always just graph these, but for this test, we're not going to have the ability to graph anything. We're not going to want to spend the time to do that, okay? So if we've got to use algebra to find the rest of them, again, we've got to use this rational root theorem, okay? And that is what we're going to learn now. Okay, here we go. So you got the polynomial, okay? Step 1 is going to be to list all the factors of the constant. What's the constant? Yeah, in this case, it's -1, okay? It's just the number at the end that's by itself, right, Kyle? Yeah, that's what a constant is, okay? There are a lot of letters in math. I know a lot of us hate that, okay? And for some reason, the math wizards have chosen that we're going to call this the letter P. I don't know the reason behind that, okay? But you're going to hear me call the constant, or the factors of the constant, the letter P, okay? Next thing we're going to do, we are going to list all the factors of the leading coefficient. The leading coefficient. Okay, we're going to call that the letter Q. What is a leading coefficient? Yeah, the number in the front, the very first number. So in this case, it would be 2. Good. Okay. The factors of the constant, or P, are going to go on the top. The factors of the leading coefficient, or Q, if you want to abbreviate, they're going on the bottom. And then we test each of them using what we call synthetic division. It's going to be our easiest method today. And we know something is a factor when the remainder is 0. Okay? Good. Good. So write that down, and I'm going to show you how this works. Okay. So this one's going to work out pretty easy just because 2 and 1 are not very big numbers, okay? So the first thing we want to do is we want to just list out all of our possibilities. I'm just going to abbreviate that. Possibilities P over Q, okay? So if we look at P, we said that was what number? -1. What will go into -1? What numbers go into 1? Just 1, okay? So a positive or a -1, right, would work. So that's it. That's all we got for P, is a plus or minus 1. Okay, and then the next thing says to list out all the factors of the leading coefficient. You told me that was 2. What numbers go into 2? 1 and 2. That's it. So plus or minus 1 and plus or minus 2. Okay, so what we have here is we have several different fractions now that we've got to simplify to actually find the possible factors, okay? So if I look, the numerator up here is just a plus or minus 1. My first denominator is also a plus or minus 1. What is 1 over 1? It is 1. And what is a -1 over 1? A -1, okay? And then if I change this back to a positive, and I had a positive over a negative or a negative over a positive, it doesn't matter. It's still going to give me 1 and -1, okay? Those are the only two factors I can get from dividing two ones. And then we move on to the next denominator. So we've got a 1 over 2. What's that going to give me? 1/2 or -1/2. That's it. That's all I can get from dividing 1 and 2. Okay. So what that tells me then is that these 4 numbers are my possible factors. No, they're not all going to be factors. We just said this is only going to have 3 answers, right? So there's no way that all 4 of those could be factors, okay? We've now just got to test them. We've got to find one that works, okay? My best advice is just start at the beginning and start ruling them out, okay? So my first factor is 1. That's going to be my first ledge guy that I'm going to test. I'm going to put my numbers going across. What are my numbers going across?
2, 1, 2.
Yep. 2, 1, -2, and -1. Good. Put a line. And now we start testing them. Drop down that 2. 2 times 1. 2. Add them up. Keep going. See if this is going to work. Is 1 going to be a factor?
Yes.
What do we think? Kyle thinks yes.
What did I do? Did it with no calculator.
You did it with no calculator. I like it. Okay, so you added 2 plus 1 to get 3. 3 times 1 is 3. Add these up to get 1. 1 times 1 is 1, and my remainder is 0. Okay? This is the best case scenario. This is when it's pretty, and this is when I love math. Okay? Is when the first one worked. So that just means right here, x equals 1 is an answer. I've got 2 more answers to find because I knew I needed 3. And I've got a polynomial left in disguise right here that I can pull out and factor. And then I'm done. Okay? If 1 wouldn't have worked though, I would have just crossed that off and I would have went to the next one. I would have tried -1. See if that worked. And if it didn't work, I'd go to the next one and then the next one. And if none of them work, you probably did something wrong in your math. Okay, so you probably need to go back. But in this case, we got 1 to work. So that's my first answer. And what is this polynomial that's left? 2, 3, and 1. It's in disguise.
2x is second power plus 3x plus 1.
Perfect. Plus 1 equals 0. You got it. Factor that. Factor that, factor that. We should know how to do that by now. Okay, how do we factor this? X method. What goes on top? 2, because 2 times 1 is 2. What goes on bottom? 3. 2 things that will multiply to 2 that will add to 3. 2 and 1. That's not hard. Okay. Now we plug those in as our middle terms. I'm going to go kind of fast just because we should know how to do this by now. Okay, we group them with a plus sign in between. I'm just going to toss in some parentheses there. 2x squared and 2x, they both have a 2 and a x. And what's going to be left? X plus 2x divided by 2x is 1. Thank you. And then we got 1x and 1. What do they both have? Just a 1. That's okay. 1 is still a factor. And then my 2 factors are going to be what?
2x plus 1.
Perfect. Thank you. And if I converted those 2 answers, just like this one, I break them apart. I set them both equal to 0. 2x minus 1 equals 0. Solve that. How would I solve that? What's it going to be? 2x plus 1 equals 0. What?
1/2.
No. Not 1/2. -1/2. And what's this one going to be? -1. Thank you. Okay, those are my 3 answers and I'm done. This is a lot of work. It's tedious. I know that, guys. Okay? But it's part of it. Play the game.
So we only have 1
On the quiz next class, yeah, we only have 1. Yep, there will only be 1 question. It will be just like that. Okay, here we go. We're going to do another one. What I need you to do right now is set up your P over Q. Okay, your possibilities. Your factors of P over Q. Write those down. Write those down. This should be the easy part, okay? What number is P? 10. So tell me, what are all the factors that go into 10? 1, 2, 5, and 10. What are all the numbers that go into Q? What is Q? 1. What goes into 1? Just 1. Okay. So now we simplify this fraction. Okay, we only have 1 denominator, which is good. Okay, because if it was more than that, this was going to get pretty long. What is 1 over 1? 1 or -1. Okay, 2 over 1. 5 over 1. And 10 over 1. Okay, holy crap, that's a lot. That's a lot, isn't it? Okay, there's a lot of possibilities here. The stupid part about math is that sometimes you'll get problems where you won't get the right answer until the very last one. And you got to keep going. Okay? I'm not telling you that it's going to be that on this one. You got to find it. So let's set up the first one. I'll set up the first one with you. The first one's not it? Okay, but what is the first one? 1. And what are my numbers going across? Okay. That's a key part, is getting those numbers right, because if you put the wrong polynomial numbers, you're never going to get a right answer. Okay? So make sure you do that. Set this up. Go ahead and try. See if this is going to work. All right, let's go ahead and try this. We drop down the 1. Now what? Yep, times them. 1 times 1 is 1. Add these up. We get -1. -1 times 1. -1, add them up. -6. Gives me a remainder of 4. Is that going to work? No. So we got to cross it off and we keep going. We go on to -1. We put the same numbers up top. I'm writing kind of big. I should have wrote smaller. Okay, we drop down the 1. 1 times -1. -1, add them up. Multiply. -2. 2. Remainder of 12. Is that going to work? Nope. Next one. What is that going to be? 2. Let's try 2.
Holy shit. Hey.
Drop down the 1. Now what? 2. 0. 0. -5. -10. 0. Bam. Got one. What is the answer? It's x equals what? 2. Okay, good. So we found one answer. How many are missing? 2 more. We need a total of 3. Okay, we're left with a polynomial in disguise, aren't we? Yeah. What is it? Yep, it's x squared minus 5. You don't need to put a 0x. Good. X squared minus 5 would be the remaining polynomial there. And then what? What is this? Is it difference of squares? Is 5 a perfect square? No. Okay. This actually goes back to our radicals unit. Okay. So we solved equations like this. We add the 5 over. We end up with x squared equals 5. And how would I solve that? Square root. What is the square root of x? It's just x. Okay. And what's the square root of 5? Just square root of 5. We can just leave it like that. Okay. But know that this would be the square root of 5. It would also be the negative square root of 5. Because those come in pairs. Okay. That's where I get my last 2 answers. That's where I get my last 2 answers. Okay. Questions for me? Do we want to do one more real quick? No? Okay, we've got a couple more blanks to fill out on these notes that I just want to go through so we don't have to worry about it next time. And then we're going to be done. You can work on your homework today. Okay, last theorem we're going to talk about today is called the fundamental theorem of algebra. That sounds important. Yeah, because it is. Okay? Is this new? No, I've been telling you this since Unit 1. Okay, this just states that the number of answers you get is based on your highest exponent. Good. Okay, I didn't tell you it was the fundamental theorem of algebra because you would have punched me in the face. Some of you would. You're getting kind of angry. You're acting like angry elves. Okay. Root zeros and x-intercepts, they all just fit into two categories, and we have talked about this already. We have talked about the different types of categories of numbers, okay? All of our life until we got to this class, we'd only dealt with real numbers, and then this year you got introduced to imaginary numbers, which are a whole different realm of numbers, okay? We knew something was an imaginary number because it had a what in it? An I, okay? Gives it away. A negative under an even root, okay? So, knowing what we know about this, for instance, this example, how many answers or roots is this going to have? 3. Awesome. You're so smart, okay? Based on then the imaginary root theorem, kind of like what I just talked about on the last problem that we did. I said anytime we're dealing with those square roots, which is when we dealt with our imaginary numbers a lot, was whenever we got like a square root of a negative, we always end up with 2 answers, okay? So these always are going to come in pairs anytime we deal with i's. They're coming in pairs. So if there's only 3 answers total, what are the possible imaginary roots that this could have? There could be 2, or there could be 1 is not an even number. 4 would be too many. 0. Yep, there could be 2 or 0. Okay. And then we do rational root theorem. We do P over Q to figure out what the possible rational roots are, because we know we're going to have at least 1, if not 3. Okay? And that's what we would do, but you said you know how to do this and you're feeling prepared, so I'm going to stop here and let you do your delta math. Okay?